Hi, boys and girls. Today is Friday of the week of April 27th, Thursday/Friday. And today we're going to focus just on friction as a force. We did a focus intensely on Wednesday on gravity. Now today it's just friction. All right, so the first kind of friction I want to talk with you guys about is air resistance, and we're going to watch a video together. But before we do, I'm pretty sure that Thomas in our last Zoom or the Zoom before last on Thursday, which is actually today for me, by the way, y'all. All right, he was asking about how the design of things or does the design matter of things when it comes to air resistance. And if you were in the Zoom meeting, I was drawing a picture that looks something like this about how when I was a kid, like back in the 70s and 80s, if I was drawing a car, I would draw it super duper boxy like this because that's kind of what the cars look like. They weren't very smooth or aerodynamic, which is a word you kind of need to know. Aerodynamic. This car, not so much. Right? So here's the deal. As this car moves along, the wind is going to hit straight on that windshield that's straight up and down, right? Kind of like a wall, and cause lots and lots of friction on this car. So what happens is this car will need a lot more fuel to be able to move anywhere because it has to fight against friction a lot more than if it has a more aerodynamic design. Now, I know my car is not the coolest, but it is pretty aerodynamic. If your parents have something like mine, one of those minivans, then they're literally designed it with a round shape, which allows the air to move over top of them, costs less money in gas, and means that your car is not having to fight against the force of friction so much in order to get to move. So the design of something really does make a difference with regard to the amount of friction that it has to deal with. And that's kind of what this video that we're getting ready to watch together is about. So let's go take a look.
Hi guys. Sometimes in science we describe things according to properties, and properties are when you describe things according to their color, their shape, their texture, their size. Like a property of me is I'm extremely beautiful and handsome, right?
Yeah, sounds like someone you know who likes to brag about herself. Okay, yeah.
Okay, maybe not, but check this out. Here I have two sheets of paper, right? Now if you look at them, they're exactly the same. Same color, same shape, put them together, same size, hold them side by side. They're exactly the same weight. But now I'm going to change a property.
Mass. Let's say mass. Or weight. But remember, weight depends on gravity. And mass is the amount of matter that something has in it.
Just on one of them, I'm going to take this piece of paper and I'm going to crumble it as hard as I can. Just going to squeeze it and squeeze it and squeeze it and make a very, very, very tight ball of paper. Now, if you look at these two sheets of paper, okay, and I asked you a question, I guarantee you're all going to get this question wrong. Which one weighs more? Is it A or is it B?
All right. Well, what do you guys think? I think since he just got done telling us the papers were exactly the same in every way, including mass, and we know that the mass stays the same from our law of conservation, of matter. So when I look at that, I don't think that squishing it would change the mass. Do you? Do you? Do you? Because I feel like that's a science law that we already learned about. So the mass should stay exactly the same. Now, on Wednesday's lesson, we did the ball drop. And when we did the ball drop, we noticed that the balls hit at about the same time, right? The thing about them is they had different masses, but their size and shape was about the same, which lends itself to this discussion today of aerodynamics. All right, let's watch and see what happens to the two papers that are exactly the same in every way, except the guy scrunched one of them.
Now, most of you are going to say it's B. And actually, they're exactly the same. All I did was change its shape. I didn't change its weight. Think about it. If you weigh 50 pounds and you put your hands in the air, you still weigh 50 pounds. If you're jumping into a pool of water and you turn your body up really tight and you're doing a cannonball, you put all of that weight into a small space, but you still weigh 50 pounds.
Now, wait a minute. When he says you put all that weight into a small space, isn't that squishing? And when matter molecules squish together, what are you changing? You can't change the mass because the mass stays the same. So, what is getting changed when you squish matter? Remember, when you add heat to matter, molecules spread. When you remove heat from matter, molecules squish. And when molecules are squished really tight, that's called density. All right, so I wonder when he squished the paper, did he change the density of the paper? Even though the mass is still the same, the molecules, instead of being flat, are instead squished together.
The weight didn't change, I changed the shape. Now, I have a cool little fun story I like doing with these papers. I'm a little weird, but let's just pretend that these papers talked. And these papers lived in Paper Town. And all of a sudden,
Okay, talking papers in Paper Town? All right, but we'll roll with it.
you have this big guy walking, and he's like, "Zh, zh, zh." And you got this small little guy walking, he's like, "Zh, zh, zh." Hey, what are you doing? Nothing. Why don't you move out of my way? Do you know who you're talking to? Yeah, someone very big. What? And very ugly. Now, of course, these papers get into this huge conflict, and then they get into this competition. They're gonna have a race, so they climb on top of a mountain. The loser has to leave town, and
Now, who's the loser in this? Which paper will lose if they're both going to the top of a mountain?
the race is this. This guy thinks because he's bigger, he's gonna hit the floor faster. So they climb on top of the mountain. Okay? Now remember, the loser, okay, has to leave town. Now let me ask you a question. If I drop these two sheets of paper at exactly the same spot, I'm changing nothing, I'm not forcing them, I'm just gonna let them go, and the only thing that's different is its shape.
All right. Now, you saw that when the two balls dropped, they dropped at the same time. And we learned that when the two balls drop, right, at the same time, it's because even though gravity does pull harder on something more massive, that more massive thing also has more inertia, which slows it down. So that makes them fall at the same time. Now, these both have the same amount of mass. Will they have the same amount of inertia, or is some other thing at play when they both are getting dropped from the top of the mountain?
The same exact thing, and I let it go. Which one is gonna hit the floor first? A or B?
Okay, make your prediction. A, the flat piece of paper. B, the ball of paper. Which one will hit first?
Make a prediction. And now let's see. 3, 2, 1. Was your prediction right? I think it was.
Was it right? Did you predict that B, the ball of paper, would fall? Now, why did the ball of paper fall faster? If what we learned on Friday, right, Wednesday, was about how they both hit at the same time. What is the thing that made them not hit? Let's hear.
The ball of paper did hit the ground first. Now, does anybody know why? Well, you see, this large sheet of paper, it was really unfair. Think about it. Underneath this large sheet of paper is what?
Air.
There's air. The ball of paper had just a little bit of air underneath it to move out of the way. This large sheet of paper, as he was falling, was moving through the air like doo-doo-doo-doo, 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 where the ball of paper had just a little bit of air to move, and it kind of was like, woohoo! Super fast. Now think about it, okay? That's what air resistance is. The air is resisting. There's resistance. So this paper has to move all of the air out of the way, and the bigger the surface, the more the air, the more resistance, the slower it falls. Now, as you saw, the large sheet of paper did move really slow. The ball of paper did move rather quickly. And you guys can do this experiment at home. Try really big sheets of paper. Try really small sheets of paper. And ultimately, you're going to realize that the object that moves super slow through the air is the object that is extremely air resistant. And the object that moves extremely fast through the air is the object that's not air resistant. So now you know a little bit about air resistance.
Yes, you do. You know a little bit about air resistance. And I might just leave it at that. And of course, as this guy has challenged you to think about doing your own air resistance experiment, that would be amazing for you to try. Let's close this out, slow it down. All right, so I'm going to let you go for now. Bye, y'all.